So today I've got an interesting video for you. I've got this Alesis Multimix Firewire mixer. It's a Multimix 12, and it makes a buzzing noise all the time on all channels, and usually this is a power supply issue with some capacitors, the filter capacitors, and I'm going to show you how this is taken out and replaced. There are a couple of other videos already on YouTube on this, and they show you which capacitors, but they don't actually show the process. So I'm going to show you the process by which we take it out and look at them and then replace them. And I also have it hooked up to this small monitor so you can hear what it sounds like. And you can hear that it buzzes when I first turn it on. If I leave it on for 10 or 15 minutes, the buzzing goes away. But when I first turn it on, it's definitely quite loud. So here goes. And you can hear it's very loud, especially on channel 1. It's there present on channel 4 also. I don't have any inputs plugged in. If I turn the gain up and down, it doesn't change anything. It's just always on there. You can hear if I have them all unplugged. It's quite loud. Sometimes these exhibit the light on the clip or the signal here will be on, but you can hear that's kind of annoying. That's coming out of the main signal, and that's just not usable. So that's usually just a filter capacitor. We're going to take it apart and replace these capacitors and get rid of the noise. So the first step on working on a piece of electrical equipment is definitely to unplug it. And you want to have certain things to help you along the way. I have this little magnetic tray that I put the screws in. It's very helpful. If I'm going to leave a piece for a while and come back to it, I also put them in little Ziploc bags so I don't lose them. But this is very nice just as I take them apart to throw them in this tin. You will need a number 2 Phillips, maybe a number 1 Phillips, maybe a number 0 Phillips screwdriver, and some other tools. You will need a soldering iron, which you'll see that in a minute. You'll be able to see all the tools that I use to do this. So I'm just going to take off the back panel. So there's some screws on the bottom. Get all the ones on the bottom. And then these 3 on the back, and then we can pull the panel off. Not all of these screws are the same. I'll try to show you the difference here. Some of these screws are machine screws, some are plastic screws. Not that the screws are plastic, but they're meant to screw into plastic. So I'll show you both of them so you can see. So you have to take care when you put them back, because as you can see that the threads on this one are quite wide. It almost looks like a wood screw. This is meant to screw into plastic. So this is one of the types of screws here. Yeah, so this is one type. And then the other type is a machine screw. And you can see the threads on that are much smaller. This is meant to thread into metal, machine thread. So when you put the screws back, either take note of where they go or just realize, is it going into plastic or is it going into metal? Is it going into the frame? If it's going into the frame, you want to use this. If it's going into the plastic casing, then you want to use the plastic ones, the plastic type screws. So all of the screws that screw into this are screwing into the plastic, are going to be the plastic type screws. These are the metal screws. And there are some metal ones here up in the front too. Okay, now we've got the screws in the back off and the screws on the bottom off. Now we can remove the plate. You want to be very careful when doing this. You don't want to snatch it apart because there are some ribbon cables in here that are kind of tight. You don't want to damage the ribbon cables for sure. If you do that, then you're going to have problems. Did I miss a screw? Oh, here we go. Okay. Okay, now I'm going to leave some of this connected. You see that I can't, it's very tight here with these cables. You can see that this one goes all the way under there. I am going to have to disconnect some of these so I can just pull this board down. I'm going to have to disconnect this cable and this ribbon cable. Sometimes it has glue here. If it has glue, you want to take a small knife and cut the glue, and not to damage this. Be very careful when removing it. Just be patient. Sometimes the entire connector, the socket will come off. That's okay too. If it just comes off, I'll just leave that off. I would prefer not the socket to come off, but that's fine. You kind of just want to wiggle it to take it off. This one, the socket came off also. No problem. Now we can drop it down like this. Okay, yeah. Now you can see what's happening here. There's not too much tension here, so I can just leave it like this, open. And this is your power supply board. So power comes into this board and then puts the board. This is your control board. So these two capacitors here are the ones that are going bad. When you take something like this apart and you're inspecting the capacitors, you want to inspect it if you can see any damage to them. Oftentimes, you probably can't see this from this distance, but I'll bring it closer in a second. Capacitors will leak out of the bottom, or they'll be bulging on the top. So this capacitor I know is bad because it's bulged out here on the top. It's dome shaped. These are flat, and this one is bulged out. So because this one's bulged out, we'll definitely replace this one, but I know this one also goes bad, so we'll go ahead and replace this one also. So I'm going to get about removing this power board so you can see that, and then I'll show you the capacitors. It's held down. This power board is held down by 4 screws, one here, one here, one here, and one here. I'll be taking those off. I will also have to disconnect all of these connections. Be very careful with these plastic clips. This one has a retention plastic clip on it, so it's got to be mashed and then removed. So we can just kind of flip that one out of the way. Okay, good enough. Sometimes it's handy to have a little screwdriver to help you get these apart. This one doesn't have to come off because this is with the board anyway, but we do need to get this one off, this one, and this one. Sometimes I like to hold the socket down with the screwdriver so I don't pull the socket off of the board. I don't really want to pull the socket off these boards. There's no retention clips on these. You just kind of wiggle them back and forth until they come out. Okay, now we've got it all disconnected. Now I need to take the 4 screws out. So now we have the power board out. And I'm going to try to show you what I mean by capacitors bulging. So you can see, like this one looks okay. You see the top of it is flat. It doesn't look very dome shaped. These also look pretty good. But this big one right here, you can see that it's bulged out on the top, right up there. It's definitely got a dome shape to the top of it. Oftentimes this one next to it also has a dome shape, but it's flattish, but it's probably on its way out anyway. We'll test it and I'll show you how to do that also if you have a multimeter. And this one is definitely dome shaped. So this is bad, this is causing problems. These are filter capacitors and they just prevent the power, the buzz, the 60 cycle hum from getting into your equipment. So we're gonna pull these out. Now you see that this is stuck to this board. You can just gently, it has this little tape. This one brace was holding it down. So we'll just gently pry it up right here under each of these pieces and get it off the board. Get it off this metal plate. So now we have the board off. Now we can look at what we're going to do here. So on this board, you can see the traces, and these are the capacitors in question. These are the ones we're going to change. You see the legs of the capacitor go through right there, and these two has also two. They have one positive, one negative. So we need to desolder both of these and pull it off the board. So I just look at where they are and I match where the legs are on the back. So you can see this one goes right through here. So I just mark the ones with a little dot, the ones I need to desolder. I need to get those two. Yeah, this one, and this one looks like it's going to go right, these two right here. All right, so we need to desolder this one and this one, both of those, pull them out, put some new capacitors in. So capacitors are kind of like batteries, but they discharge their electricity a little bit faster, and they do store energy. This is 35 volt capacitor with 2,200 microfarads. So you want to get the same capacitor to match this. It's got to be 35 volts and 2,200 microfarads, that's mu F. This is a measure of capacitance, and this one you see is 35 volts and 1,000 microfarads. So I've gotten some replacement capacitors. I ordered these from Mauser Electronics. You can find them anywhere. Notice these are Nichicon. This is a Japanese-made capacitor. It's very good. It's made for audio quality. If you replace capacitors, you don't want to buy cheap capacitors. They don't last very long, and you just may as well spend a few cents more and get the real deal. Japanese-made capacitors are really good, so Nichicon is known to be one of the best. You see this is a 2,200 microfarad, and this other one is a 1,000. They're both 35 volt, just like the other ones. This one is a little bit bigger, so it's going to be a little bit tight on the board, but it won't matter. We'll get it in there. When you have capacitors, what you want to notice is that one leg is longer than the other. You can see that this leg is longer than that one, and this one is longer than that one. Capacitors have polarity, so the longer leg is your positive. This is going to be your negative. Usually they're marked on the side. You see that this side has the black with the negative, and the negative is the shorter side. Same thing on this one. The negative is marked there, and then this is the shorter leg, so this is the positive. Usually the PCB boards are marked which one is positive and negative. If it's not, you definitely want to take note of that because you don't want to pull it off and then disorient them. But you can see here that it's marked right down there. You can see that leg on that 1000 one says positive, and over here the right leg says positive. So we're going to put the positive leg on that side when we put them back. Okay, now we're ready to do some desoldering. So I've got my soldering iron here warming up. You're going to need some stuff in order to do this. It's always handy to have some soldering flux. This is a cleaning agent that helps the solder to adhere. It's kind of a goo. I usually just use it out of the lid. Also very handy to have some solder wick. This pulls the solder off the board to help us get the capacitors off and clean it up when we're ready to resolder them. The wick absorbs the solder into the wick as you heat it up. I'll show you how to do that. And you'll definitely need some cutters and some solder, of course, just enough to do this job. So pulling these out can be kind of a trick sometimes. This is not too bad because it's just two of them. You want to be careful not to damage any of the other capacitors or break them off, because then you'll have to replace those two. So what I'm going to do here is just apply gentle pressure and pull these out as I warm it up. We know it's that one and that one. I'm going to desolder this one first, then I'm going to get this one. When you're soldering, you must realize that having solder helps to transfer the heat. Having a little bit of solder on your soldering iron. And note that the solder will flow towards the heat. So when you want to solder things together, if you want to solder it, you want to put your iron here and pull the solder through whatever you're trying to solder. In this case, I'm just trying to desolder them, so I'm just going to apply it until it gets hot. So as I'm heating it up, I'm also pushing it through the board and pushing the legs with the soldering iron, and I'm warming it up, and I almost got it out. That one popped out. There we go, and that one popped out. There we go, we got this one. I'm going to clean these legs up a little bit because I want to test them. I'll show you that too. All right, there's one. I'll drag the other one out. Same process. Want to be careful not to desolder anything else. Okay, got that one too. Good. You don't have to do this. I'm just getting the solder off so it'll go inside of my tester. Okay. So now we've got the capacitors out, as you can see. Now we will test it. So now I'm going to show you that these capacitors are probably bad. Definitely this bulging one. I know it's bad. And probably this one. So to test for capacitance, you put it on F, which is farads, and this is rated at 2,200 microfarads. And my meter will not even go that high, but we'll see. My meter, some meters you can just clip it on the legs. My meter, I have to insert it into these slots. This is the negative, the positive is on the right, so I'm just going to orient it that way. And it has contacts inside that will read it. So you'll see when I stick it in here, we'll see what it reads out. So you see the capacitance drop down very quickly. no, this is supposed to be reading 2,200. So it's reading 400. That's like a fifth of its capacity. Yeah, this is no good. Yeah. It will increase slightly, but it's not even close to 2,000 what it's rated at. Compare that with this brand new Nichicon capacitor. We'll also test it so you can see. And we'll stick positive over here like this. And you can see how quickly that goes all the way up to 2,000, and it's going to overload. Yeah. Let's see if we can test this 1,000. I don't know if the legs are long enough to fit in here. That one seemed like it was over capacitance, but it is still holding at 1,000. We'll try it again. This one does seem to be okay. Still close. But we may as well change it because I know it's tendency to fail. So while we're here, we'll go ahead and replace it. This one does seem to be okay. Again, this one wasn't bulging. Capacitors are also something that you don't want to reuse from circuit board to circuit board. They're so cheap that you may as well just get a new one. I mean, this thing is probably $1.70, not very expensive, even for top quality stuff. I'll show you this 1,000 microfarad capacitor. It's a new Nichicon. You see that it also goes up right to 1,000. There we go. Very nice. Now you won't be able to test the voltage through it because it hasn't been charged, but you can test resistance through them. So we can also compare that. We'll put it on 200,000 ohms, and we'll test the resistance of these. So I'll test the new one. This is the 2200 one. We'll put the negative here, and we'll test the resistance here. Not that that matters, but so you can see that that's reading about 4,000, 5,000 ohms. Okay. Let's check this one. You see that one is much higher. Having that much resistance means that it's very open. Let's look at this 1,000. This is the 1,000 microfarad. Remember, short leg is negative. The long one is positive. Yeah, that one's reading good. Let's look at this. I suspect this one will be pretty close also, because this one was testing good for microfarads. Not as good though, you see? That one is on its way out. It's already at 100,000. So it's good that we're changing it. Okay. So that is the test, how we can check them. I did forget to mention that you might be wondering, well, if you have a lead, why can't you just check the capacitor while it's on the board? And this is just not possible to get a perfectly accurate reading because of the rest of the circuitry. You'll be reading along with the other components. So to really get an accurate test, you have to desolder it from the board and test it as I did to get an accurate testing on the capacitance on the farads of those capacitors. So you can't just test it on the board. That doesn't work well. Okay, now we're ready to resolder these new capacitors in here. In order to do that, I have to get the old solder out of these holes so I can get this in there. So I'm going to use the wick to pull the solder out. And then we will put them back in there. So in order to do this, you just want to place this on top of where you want to solder it, or where you want to take the solder off. I just go to the next cleanest place on my wick, and I'm just going to put it there and draw the solder right into the wick. And just kind of roll it around there. Can you see that? I don't know if you can see the hole through it, but now the solder's out of that, so I can get it through there. We'll go to the next one. Now, I hope you can see that I've desoldered. I can see through them. So now I'll be able to put the legs through there and resolder them. That one has a little bit left in it, but I think I can still get the leg through it. Okay. So you also want to remember where they go. This was the 2200. This was the 1000 microfarad, so make sure you put them in the right place. Also, it's showing positive on this side, negative on this side. So I want the black stripe to go towards the negative, and we'll stick it through the board. Just like this. Now there's probably not room enough in the board for this to stick up this high, so I'm going to leave some of it open, out, and then bend it over so that it fits down like this in its place, just like that. So I'll put this one in here like that, and you can spread the legs apart here just a little bit to hold it in place once you get it where you want, like that. And now we'll go ahead and solder this one in place. It may be helpful to have some flux. I'll just put a little bit of flux on this. Now, I'm just going to heat it up here. I might have to put a little bit of solder here. That's that one. That one. Nice. You can tell when the solder flows, it will kind of, when it just flows and fills up the gaps and gets really smooth, then that's good. It's a good solder joint. If it's clumped and bulky, it's not. If it's not clean, it won't solder well. So you can see that does look pretty good there. So now soldered in there. I will clean it up a little bit once I get it. Once I cut the ends off, let's get the other one soldered in there. All right, same thing on the other one. Now, there's not a lot of room here, so I'm just going to gently bend this a little bit out of the way. Maybe bend this one a little bit out of the way so I can get this end thing in here. It will fit. We'll bend this one a little bit this way. Okay, positive goes on the left. The way I have it oriented here, positive is going to be on this one. So I want the longer leg, black stripe to the right. Stick it through here. Yeah, okay, I might have to desolder that one. That one that didn't have too much solder in it, I'm gonna have to wick that out a little bit. It won't go through there. Still no, huh? Okay. All right, here we go. So here we go. Now we got them in there. Solder in. Now this side, I'm going to solder this way because I don't want to desolder these ones or get those hot, so I'm going to put my soldering iron on this side. Okay, now we've got them both soldered in there. Clip the ends off. Got some flush cutters here. Clip the ends off and put them in the trash. You don't want to clip it flush, you want to leave a little bit sticking up, just a little bit. Alright, so now I am going to make sure the solder is nice and smooth. Just warm them up just a little bit. Okay. Now, we've got them back in there. Soldering joints look pretty good. Looks like it's making good contact. They sit well on the board. Now it's time for reassembly and testing. Reattaching the power supply. Put our plate back on there. This goes in like this. This sits down on top of those. And that goes under there like that. You don't tighten up all your screws until you get them all started. So if you have to move it around a little bit, you still can. Okay, now plug everything back in. Okay. Final screws. And we'll fire it up. Okay, it's all back together now. Now we can give it a test and see if we've done anything. So we're ready to test it. Before I put all the knobs and faders back on, plastic knobs, I am going to test it out to see if we've done anything, if it's going to work. Just in case I had to tear it back down, I don't want to have to pull all that off again. So hook up the power supply, hook up an output to this so we can hear it, and I'll be using a test tone out of my cable tester. We'll turn this up maybe halfway. Okay, and we'll put this into here. Let's see if we get power. Okay, so far so good. It is powered up. Button check. All looks good. Turn the mains up. Turn these up. I'll unmute everything. Okay. I don't hear any noise at all. Let's see if we have some output. You can see the faders work nicely now. There's no noise on them.